this particular module, I am going to highlight two important advanced concepts, which are advanced in the sense that you may or may not use them for building your IIoT for a specific industrial problem, but these will help you to do efficient network setup, for efficient network management and so on, and also for securing the system. These are important, these are not mandatory, but are definitely important, and I would recommend that one should consider these technologies for implementation in a real IIoT setup that is being made. So, these two technologies are number one, the software defined networks, and number two, the security. Security is more common, which is more applicable, usefulness of security is quite imminent, but SDN is something whose benefits will be clearer to you in this particular lecture once we go through all the different concepts that we are going to. So, what is this SDN? What is software defined networks, and where does it position itself in the IIoT context? Software defined networks basically targets to have efficient and more effective representative network management in the IIoT setting. It is not necessary that SDN has to work only with IIoT, but because this particular course focuses on IIoT, we are going to talk about SDN in the context of IIoT, but SDN applies for any kind of networks and also for networks such as your traditional internet, other different types of wireless networks, and definitely for industrial IoT and IoT in general. So, efficient and effective network management, how it is going to be done? If we are talking about IIoT specifically, the nature of traffic, the requirements from the organizations, these basically are non-static. These basically change with time. The traffic, the nature of traffic, the requirements of the traffic, the requirements from the clients, the specific installations, the machinery, everything is dynamic, they change with time. So, if we are talking about network management, static traditional network management techniques are not very suitable to cater to the requirements of dynamism. They could indeed be used, but if we are talking about autonomous deployments, autonomous setups and so on, it is important to cater to the dynamic requirements as much autonomously as possible. Take for instance the routing tables, routing in a traditional network. Routing in a traditional network, basically you have routing tables which are stored, which are pre-configured in different routers, switches and so on. These routing tables will basically help the data packets that are coming to these devices to know where they are going to go to. So, and these rules basically are fixed rules which are embedded in each of these different devices, the routers, switches and so on. But if the traffic requirements change, if the overall requirements of the system changes, if the system architecture changes over time, then static rule based routing mechanisms are not very suitable. This is just an example that I just gave you, and you can extrapolate it to cater to the other different types of requirements, scenarios and so on. So, for which you need to have dynamic mechanisms in place. So, SDN is one such technology which can help you to address the requirements of dynamism that are there in most of these industrial communication settings. So, what is this SDN? In SDN, we are typically talking about decoupling of the data plane from, or the decoupling of the control plane from the data plane. So, earlier traditionally in most of these switches, routers that are used in the internet conventionally used to have everything together. The control mechanism, the data, everything is basically stored, pre-configured, static in each of these individual network equipments like your router, switches and so on. In SDN, what we are talking about is how you can separate out the control from these individual data that are stored in each of these different network equipments, and have a separate layer which is the control layer, having an entity, a network entity which is termed as the controller. So, that controller is the one which is going to control each of these different network entities which are there, like switches, routers, etc. And this controller entity, the network entity controller, basically is going to help in controlling each of these different devices which are part of the data plane. So, what is this SDN? It is the restructuring of the current network infrastructure for improved network management. So, when we talk about restructuring, as this particular term, the qualifier, suggests that it is not a new technology, but a technology that will help you to re-engineer, to reshape, to relook at the current network, the conventional network architecture, and provide an efficient mechanism of doing things. So, how it is done? As I told you earlier, it can be done by separating out the control plane from the data plane, a process of decoupling that will have to happen, and by which the traditional forwarding devices will only take care of what they are instructed to do by the controller, the control plane equipment. So, holistically, this is how this SDN architecture is going to look like. So, this SDN architecture, irrespective of whether it caters to the IIoT or IoT traffic or not, is going to have three different layers broadly. One is your data layer, second is the control layer, and third is the application layer. So, we have three different layers. Layer 1 devices are like forwarding devices like your routers, etc., these different forwarding devices. Layer 2 device is the controller, which basically also takes care of the network operating system, which runs the network operating system, and then you have the applications which are running on the very top in the layer 3. This is this application layer where your business logic, your different applications are running. So, basically you have three different layers. So, the ones which are below these layers, which are below the controller or the control layer, this basically is known as the southbound API. Ones which are above are known as the northbound API. So, there are two APIs, right, application programming interface, one interface between this control layer and the application layer. So, this is one interface over here and this is another interface. So, this interface is known as the northbound API and this particular interface is known as the southbound API. So, the southbound API, in other words, basically concerns the interface between the control layer and the data layer, whereas the northbound API concerns the interface between the control layer and the application layer. So, there are different components of the SDN. Northbound and southbound APIs are the ones that I just mentioned. Likewise, there is this controller, which is a logical centralized entity which is basically controlling these different data layer devices. There are forwarding devices in the data layer, which basically takes care of mere forwarding based on the rules that are basically implemented in them, that are configured in them. You also have to support this entire stuff, you have to have some protocol which is going to help you to do whatever I just explained earlier. So, there is a very popular protocol which is known as the open flow protocol, which is specifically designed to cater to the requirements and the necessities of supporting SDN in a network. Software defined networks basically will be supported by this open flow protocol. The protocol started from the 1.1 version and currently it is at 1.5. So, OpenFlow 1.5 is the protocol that is OpenFlow protocol, that is the latest one which could be used, and each of these different protocols and its different versions 1.1, 1.2 till 1.5 has its own individual features, but holistically OpenFlow as a whole will cater to the configuration of SDN in a particular network. And on the top you have these different applications. So, these are these different components of SDN. So, these apply, as I said earlier, to any kind of network, wired, internet, wireless or IoT or IIoT, but IoT or IIoT has its own specific requirements, and the configuration of the deployment of SDN for IoT IIoT is something that is non-trivial. So, before we discuss about those non-trivialities, let us talk about some of these different aspects. So, in SDN we need to understand few different concepts which will make us to understand further how SDN can cater to the requirements of IIoT. Number one is rule placement, second is controller placement, and third is security. Rule placement, controller placement and security are the three most important concepts that one should know in SDN. So, let us try to go through each of these. There are different research papers that talk about different ways of rule placement, different ways of controller placement, different security mechanisms and so on, but we will go through some of these very naive high level views of each of these different concepts to make us understand what these are. So, in the rule placement, basically what we are talking about is that we have different forwarding devices that forward the incoming traffic based on certain control logic that is again defined by the SDN controller, and this control logic is basically placed at the devices, that means in the data layer, in the form of something known as the flow rule, and it is this flow rule that we are talking about in this particular context. Before we talk any further, I should also tell you something else. These flow rules are basically stored in a memory in each of these devices, which is known as the TCAM memory, the full form of which is ternary content addressable memory, that are there. The TCAM memory are there in each of these devices, that means the data plane devices, that means your router or the forwarding devices, you have all these TCAM memory that are there, which will store the different flow rules. Now, this TCAM memory is very small, and consequently this TCAM memory in each of these forwarding devices will store only a limited number of flow rules. So, this only a limited number of flow rules can be stored, and that makes the life challenging about how you are going to design your flow rules and so on, because you have very limited space in the TCAM which can store your flow rules. If that was not there, you could have, if that constraint was not there, you could have a bunch of different flow rules all being stored in the TCAM memory for further use, but because that constraint is there, you need to now know how you are going to design your flow rules, where you are going to place, how you are going to place and so on of these different rules. So, let us now try to understand further how this TCAM and this flow rule placement is going to work together. What is this constraint all about, and we have to try to appreciate how this constraint is going to bring in these different issues which will have to be addressed. So, let us say that you have all these different flows that are coming, right. So, let us say that first you have two different flows like the ones that are shown over here. You have two different flows, like the ones, let us say that these two flows have already come in. So, the flow rule for the first two flows are already inserted because that was not already there. So, it is already inserted in your TCAM. So, then corresponding actions for these different flow rules are also mentioned in that data plane. So, basically you have for each of these flow rules, you have the corresponding actions that are also specified. So, if certain traffic comes next, so what is going to happen is this matching is going to be done with this particular flow rule, and based on this particular matching, if the matching happens, then the corresponding action that is specified against these flow rules are going to be taken. So, these actions are going to be taken. Now, let us say that you have a third incoming flow that comes. This is this third one. Let us say that we have to deal with this third one. So, first and second already dealt with, stored over here. So, 1 and 2 already stored. Now, the third one comes. So, let us say that this particular TCAM memory can store only 2 flow rules. The third one comes and it will have to be either inserted to give the constraint, to specify that constraint in this particular table, or how do you deal with it? How do you deal with it? So, how do you accommodate this new flow? There are 2 ways. One way is that you delete one existing rule and you insert the third one. The other possibility is that you have to combine. So, you can, using some wildcard or other mechanisms, you can have combined rules which will cater to multiple such rules together, which will combine multiple rules together. For example, over here you can have S10.0.0.2 and here also you have S10.0.0.10. So, you can have a wildcard and you could have something like S10.0.0. which will match both, but then although you can combine in the using a wildcard like star etc., you could combine these two in the form of one rule, but then that will also not make it very specific, right. So, those constants are also there, but in certain cases this kind of combination will make sense and one could use. So, what we have seen is that a TCAM memory has its own different constraints. We could only store few rules in it, and if you have a additional rule coming in which cannot be stored, then it has to be handled in a certain way. Wildcard mechanism is one, but then it has its own disadvantages. So, let us look further. So, that was the rule placement, and one problem with rule placement, like this there are so many different problems, these different research papers that talk about rule placement in SDN deal with, and they identify the problems, they solve those problems and so on, but I think it is sufficient in a short lecture like this to know only what the main issue is and what are the different aspects of it. The next issue is the controller placement. In controller placement, we are typically talking about issues of dealing with identifying the number of controllers that might be required in a particular setting, identifying what should be there to be placed, how you are going to place it, which architecture will be followed, whether it is going to be a flat architecture, hierarchical architecture or other architectures that might be used to place the controller, and whether we are going to have some kind of fault tolerance in the event that some entity, maybe the main controller fails, whether we are going to have fault tolerance to adopt a backup controller to be also in place which will take over if the main controller fails. So, all of these different controller placement issues are the common ones that are researched in the literature, and different solutions are provided. Security issues like installing firewalls, dealing with denial of service attacks, offering reliable secure connection between the controller and the forwarding devices in the data layer. These are some of these different security issues that are also of concern in the context of SDN. Different applications serving different requirements such as network management for backbone internet, traffic engineering, load balancing, dynamic access control between the user and the access points, mobility management. These are some of the issues that are researched, and there are different solutions to them. I have cited some of these different literature in case you are interested to know about in detail about any of these different issues, their corresponding applications in SDN and so on. Then these are some of these different research literature that one could go through. These are some of these different papers that belong to us. We are the ones who have authored these papers in our research group. So, you could go through these. There are many other papers on SDN that we have authored. In case you are interested, you are encouraged to go through my Google Scholar profile. You will be able to go through you will be able to find the corresponding literature, the works that we have done on SDN, and if you are interested further, you can go through them, and if you are in doubt, you could connect with me regarding any of these different papers that we have on SDN. Different other issues such as the issues of management, sensor network management, application level issues, IIoT, IoT and so on. These are some of these papers again that belong to our research group, and you are encouraged to go through them along with the other research papers that I have listed over here in these 2 slides. So, let us now get into the issue of SDN for IoT. So far what I have made you understand is what SDN is and what is the overall architecture of SDN, what are these different components of SDN, what are these different APIs, the northbound API and the southbound API and so on, and the different protocols that will have to be used in order to deal with with SDN, because SDN has its own different characteristics, features and requirements. So, you need to have specific protocols to deal with it. The OpenFlow versions 1.1 to 1.5, these different versions of the OpenFlow protocol is a popular one that is used for catering to the requirements of SDN. So, let us now look at IIoT, catering to the IIoT scenarios, industrial IoT, industrial machinery fitted with different sensors, actuators and so on, and software defined IIoT, what is this architecture. So, this is this architecture that I have taken from this particular reference that you see in front of you. So, so basically what you have in a software defined IIoT scenario, at the very bottom is the layer which deals with these machines which are fitted with the different sensors. This is your machines. These machines could be any industrial machinery, manufacturing machinery, power machinery and so on. So, any machinery basically which has these different devices such as sensors, actuators and so on. These are fitted, these sensors, actuators etc., these are fitted through this interface layer, interface board having these sensors, actuators on top of these actual physical machines. And then you have this controller, these are basically your device layer, this is your control layer, controller, and then you have on top you have this the cloud which basically caters to these business applications, business logic, pricing, billing, analytics and so on, security and so on. So, this particular API is your southbound API over here, and this is your northbound API. So, these 2 APIs are over here catering to these different requirements. So, there are different challenges or requirements in IIoT network, challenges with respect to network segmentation, challenges with respect to having policy based data forwarding, remote control of different devices and their functionalities, and offering security. Security is there all through. So, basically security issues I am not going to go through in detail, but mind you that security is very important, and it is even more important in the context of IIoT and particularly SDN. SDN implemented on IIoT. So, what is this network segmentation? So, network segmentation, we are talking about segmenting the network dynamically with the help of these different rules to have one part of the network follow certain requirement and the other part, the other segment of the network follow other requirements and rules. So, let me just show you what I mean by this. So, what we are talking about in this context is, let us say that you have a certain network like this. So, we are talking about in network segmentation having let us say that coming up with certain rule which will partition this network or segment this particular network into 2 dynamically based on a certain policy or a certain rule. So, rule based partitioning, it is going to happen, and it is going to happen dynamically. So, that one part of the network, this network partition 1 and network partition 2, these are going to work together, but will follow different rules. This will follow, let us say, rule 1 and this will follow rule 2. So, rule 1 could be like at the transport layer, this could be following, let us say, UDP, whereas this part of the network part 2 will follow maybe TCP. This is just an example, but you could have different other policies implemented in the different parts of the network, and this is very, very important in the context of IIoT. The reason is that in IIoT you have a large industrial setting, and in this large industrial setting consisting of large different types of machinery, not all of which are homogeneous, all of which are catering to different requirements and so on. Some machinery might be catering to real time, ultra real time requirements, whereas other parts of the other machinery and other parts of the system, that other parts of the network might be catering to other non real time requirements and so on. So, basically segmenting this network dynamically based on certain rules, based on certain policies, and having them run different protocols, different policies, etc., is very important in a industrial or manufacturing power plant manufacturing setting. So, policy based data forwarding is the second one. So, here we are talking about different in a context of IIoT, we are talking about the use of sensors and actuators again, and they will have to be placed to monitor or actuate real time status of certain industrial requirement, and these forwarding policies will need to be implemented, and they will so in many cases they will change dynamically depending on the requirements, the real time situation that is there. So, these will have to change. For example, temperature data may have higher priority compared to humidity data or vice versa, and in different parts of different periods of implementation, different time periods, basically these requirements may also change. In certain parts of the network at certain points will have higher priority, let us say, to the temperature data, whereas in the other instances of the time domain, basically it might so happen that the humidity will have more priority over the temperature and so on. To dynamically cater to these kind of requirements, changing requirements and so on, SDN is useful, and this is even particularly useful for IIoT requirements of this particular sort, the example of which I just gave you. So, rule based forwarding policies in SDN would be able to meet the dynamic change in the requirements of IIoT. Remote control of the devices functionalities is very important. Remote actuation, remote control of these different devices is important, and SDN can cater to this particular requirement in a dynamic fashion. As and when and the requirement changes, it can be done. So, these things are very important. Security, as I told you before, we are talking about the security of an SDN enabled with SDN enabled on top of IIoT. So, flow based forwarding has its own security vulnerabilities, and also different DOS attacks can be performed, and we can think of these different vulnerabilities where the DOS attacks can be performed in the case of use of SDN and so on. So, taking care of these issues, implementing security protocols in the controller, for instance, is very important. So, taking care of all these different issues is very important. So, you need to have a security layer basically implemented, or it can be implemented vertically across all these different layers. This is very important from the point of view of implementation of security, either horizontally or vertically across the different layers of SDN for IIoT. So, there are different requirements which will have to be taken into account to build SDN enabled IIoT systems. So, for example, low latency virtualization is a very important requirement. So, here actually software defined also brings into picture the necessity of virtualization, network virtualization, storage virtualization and so on. So, low latency, that means in very little less time you will have to cater to these virtualization requirements, because you are dealing with industrial machinery operating in very high speeds, throwing large amount of data, actuating in very high speed and so on. So, low latency is very important, that means in very less time the things are going to be done. Low latency virtualization, that means virtualization in very less time, least time virtualization will have to be done in order to cater to all these high speed requirements, real time requirements and so on. Deterministic networking is very important here. It is very important in SDIIoT scenarios to have the logical centralized view of the network, logical instantiation of the physical network and so on. And rule based priority forwarding has to be implemented to enable deterministic forwarding of traffic over the network, so that the events are processed in order. High availability is very important, fault tolerance feature is very important. We are talking about industrial machinery dealing with carrier grade telecommunication equipments, protocols and so on. So, high availability with fault tolerance ensuring there is least downtime if at all there is any. These are very important considerations of SDIIoT. Security, I have time and again talked about security issues, robust security mechanisms, taking care of all of these different issues of SDN and SDN over IIoT is very important. Applications, up to date applications, having open architecture of devices, running different administrator specific requirements and making them up to date in a cost effective secure manner is also very important for SDIIoT. So, if we look at the current state of practice in the case of automation in industries. So, this is a global view, an architectural view of of automation as it currently stands now. So, basically you will have in the case of automation in these settings, you are going to have different levels, right. So, you have level 0, you are going to have level 0 sensors, basically the having different sensor equipments. Level 0, level 1 is going to be the digital controller and the controller devices and so on. Level 2 is going to be the supervisory control like SCADA, PLC, HMI and so on and so forth. And level 3 is going to be dealing with all these different applications, computation, business logic implementation, analytics and so on. This is the typical layered architecture of automation as it stands now. Now, if you want to implement SDIIoT on these kind of settings, you are going to have something like that. This is the holistic pictorial view of software defined IIoT or software defined automation. So, unlike in the previous scenario, what we are going to have over here is something like this. You are going to have levels 1 to 3 from before in this virtualized system. So, basically these levels 1 to 3 will deal with stuff like software defined digital controllers, software defined PLCs, software defined data acquisition systems, software defined HMI, process control and so on. And so, these are going to be software defined virtualized systems, virtualized instances and so on. And in level 0, you are going to have these virtualized servers that will interface with the sensors and the physical devices via the data center networks. So, with this we come to an end of this particular part of the software defined networks for IIoT. We have gone through the different examples of the use of software defined networks for IIoT, the different requirements, the challenges and so on. We have also gone through the overall architecture of SDN and thereafter how it applies to catering to the requirements of automation in most of these different advanced manufacturing industries where automation is required and so on. And we have also finally looked at the overall architecture of how you can transform the software defined, how you can transform automation architecture that is typically encountered in the IIoT settings in these industries or the manufacturing plants and so on, to the automation software defined automation architecture, where you are going to have the logical view, the virtualized instances of all these controllers, the overall SCADA controller, the controller devices and so on, and also the virtualized instances of these different servers at the bottom and so on. So, you are going to have reduced number of layers in the virtualized or software defined automation architecture. These are some of these references which have been given to you as usual for growing your curiosity further in order to understand these concepts in further depth if you are further interested to know them in detail. So, these are these different references, and with this we come to an end of this part of the lecture on software defined IIoT. Thank you.